The triode is not unfamiliar to us. It is a basic electronic component, which is used in current amplifying circuits, electronic switching circuits, voltage amplification circuits. In this class, the teacher will take you to know the triode and learn how to measure it. According to power, triode can be divided into high power triode, medium power transistors, low power triode. The figure shows a high power triode. High power triode have relatively high power, which causes a large amount of heat. Triode, most high power transistors use metal shells to facilitate heat dissipation. This is a medium power triode. Medium power triode generate heat during operation. Therefore, the back of the triode is made of metal, with heat sinks installed on the back to facilitate heat dissipation. This is a low power triode. Small power triode have low power. With small heat generation, generally no heat sink is required. According to the material, triode can be divided into silicon transistors and germanium triode. According to the structure, triode can be divided into NPN and PNP types. The symbols of NPN and PNP are shown in the figure below. Next, we will learn the basic knowledge needed to measure a triode. Before measuring the triode, we need to consult the manual. Find the type of the triode of this model, whether it is MPN or PNP, and find the pins corresponding to the triodes B, E and C of the C level. Different types of triode. The measurement methods are different. For MPN type triode, its internal structure is shown in the figure below. Ni transistors can be equivalent to 2 diodes back to back. Triode, the measurement of a transistor, can be converted to the measurement of a diode. For a PNP triode, the internal structure is shown in the figure below. PNP triode can be equivalent to 2 diodes facing each other. Therefore, the measurement of a triode can be converted into a diode measurement. Next, we will take a small power triode as an example to learn to measure transistors and judge the quality of the triode. First, we take out the multimeter. Set the multimeter to the diode measurement setting. Now we check if the multimeter is working properly. Touch the probes to each other. We see the data on the multimeter display. If the reading on the multimeter is close to 0, it means the multimeter is normal. It can be used to measure triode. Next, we start to measure the triode. Measuring a triode is divided into 3. First, by referring to the triode manual. We know that the transistor is an NPN type. The pins of the triode are shown in the figure. There is a diode inside the B pole and the C pole. The positive pole is B, and negative is C. The internal of B and E is a diode. The positive pole is B, and negative pole is E. The second step is to measure the diode between BC. Connect the red probe to the anode of the diode, and the black probe to the cathode. When measuring, make sure the probes and diode pins are in good contact. After connecting, check the multimeter display reading. This data is the forward conduction of diode. VOLTAGE. Drop. If the displayed value is between 0.1 and 0.9, it means the diode is forward conducting. The value is 0.564. It means the diode is normal in forward direction. The second step is reverse measurement. Reverse measurement is to connect the black probe of multimeter to anode and the red probe to the anode of the diode. If the multimeter display shows OLL, it means the diode is reverse blocking, and the value indicates that the diode is normal. In reverse, when forward conduction and reverse cut off, we can determine that the diode inside BC is good. The third step is to measure the diode inside B. The steps to measure the diode inside B is the same as the internal diode of BC. We first perform a forward measurement. Connect the red probe to the anode of the diode and the black probe to the anode of the diode. Check the value displayed on the multimeter screen. The value is between 0.1 and 0.9. It indicates that the diode is forward conducting, which is normal. The second step is reverse measurement. Connect the black probe of multimeter to the anode and the red probe to the cathode of the diode. The multimeter display shows .OLL. It means the diode is reverse blocking. The diode is normal in reverse direction. Forward conduction, reverse cutoff. Then we can determine whether the internal diodes of BC are good. At this time, both the internal diodes of B and BC are good. It means the triode can be used normally. After use, rotate the multimeter to the off position to prevent battery power from being consumed due to long-term disuse. Note 1. When measuring, make sure the probes and pins are in good contact. If the contact is poor, it will cause unstable readings of the multimeter. Second, the multimeter battery must be fully charged, otherwise it will affect the measurement accuracy. Through this lesson, you have a deeper understanding of the steps of measuring triodes. I hope you practice more after class. Combine practice with theory and improve your professional skills.